Welcome to Chillin' 101. We hope this video helps.
You have the function, now act. First, state the domain so you know where to plot. Next, find y-intercept with x equals 0 and x-intercepts by solving f, x equals 0, mark them. Once done, test symmetry by checking f, x to reduce work. Even functions reflect across y-axis, odd across origin. Also scan for obvious discontinuities like division by 0 or square root domains. Make a small table of x values around intercepts and discontinuities so you can plot reliable points immediately. You should now reveal the curve story. Compute f, x, to locate critical points where slope is 0 or undefined. Use those to determine increasing versus decreasing intervals. Once done, compute f, x, to identify concave up/down regions and inflection points where concavity changes. Meanwhile, evaluate limits at problematic x values and as x approaches plus or minus infinity to find vertical or horizontal/slant asymptotes. Make a more detailed table combining x, f, x, f, x, f, x to guide your finishing the graph. Plot your table points and key features like intercepts, extrema, and inflection points, then connect them with a smooth curve that follows concavity and slope signs. Make asymptotes visible as dashed lines and label scales and critical values so the graph communicates the function's behavior. Once done, verify with a few extra sample x values. If something looks off, recheck the domain restrictions, algebraic simplification, sign mistakes in derivatives, and whether your axis scaling distorted the shape. Fix and redraw as needed.
Thanks for watching. Consider subscribing if we helped you.